Python, programming language. Published by Wikipedia. Python is a high-level, general-purpose programming language. Its design philosophy emphasizes code readability with the use of significant indentation. Python is dynamically type-checked and garbage-collected. It supports multiple programming paradigms, including structured, object-oriented, and functional programming. It is often described as a batteries included language due to its comprehensive standard library. Guido van Rossum began working on Python in the late 1980s as a successor to the ABC programming language and first released it in 1991 as Python 0.9.0. Python 2.0 was released in 2000. Python 3.0, released in 2008, was a major revision not completely backward compatible with earlier versions. Python 2.7.18, released in 2020, was the last release of Python 2. Python consistently ranks as one of the most popular programming languages, and has gained widespread use in the machine learning community. History. Python was conceived in the late 1980s by Guido van Rossum at Centrum Wiskunde and Informatica in the Netherlands as a successor to the ABC programming language, which was inspired by SETL, capable of exception handling and interfacing with the Amoeba operating system. Its implementation began in December 1989. Van Rossum shouldered sole responsibility for the project, as the lead developer, until the 12th of July 2018, when he announced his permanent vacation from his responsibilities as Python's benevolent dictator for life, a title the Python community bestowed upon him to reflect his long-term commitment as the project's chief decision-maker. In January 2019, active Python core developers elected a 5-member steering council to lead the project. The name Python is said to come from the British comedy series Monty Python's Flying Circus. Python 2.0 was released on the 16th of October 2000, with many major new features such as list comprehensions, cycle detecting garbage collection, reference counting, and Unicode support. Python 2.7's end of life was initially set for 2015, then postponed to 2020 out of concern that a large body of existing code could not easily be forward-ported to Python 3. No further security patches or other improvements will be released for it. While Python 2.7 and older versions are officially unsupported, a different unofficial Python implementation, PyPy, continues to support Python 2, i.e., 2.7.18+, with the plus meaning backported security updates. Python 3.0 was released on the 3rd of December 2008, with some new semantics and changed syntax. At least every Python release since 3.5 has added some syntax to the language, and a few later releases have dropped outdated modules, or changed semantics, at least in a minor way. Since the 7th of October 2024, Python 3.13 is the latest stable release, and, for few more months, 3.12 are the only releases with active support including for bug fixes, and Python 3.9 is the oldest supported version of Python, due to Python 3.8 reaching end of life. Starting with 3.13, it and later versions have 2 years of full support, followed by 3 years of security support. Security updates were expedited in 2021, since all Python versions were insecure because of security issues leading to possible remote code execution and web cache poisoning. Python 3.10 added the union type operator and the match and case keywords. 3.11 expanded exception handling functionality. Python 3.12 added the new keyword type. Notable changes in 3.11 from 3.10 include increased program execution speed and improved error reporting. Python 3.11 claims to be between 10 and 60% faster than Python 3.10, and Python 3.12 adds another 5% on top of that. It also has improved error messages, and many other changes. Python 3.13 introduces more syntax for types, a new and improved interactive interpreter, featuring multi-line editing and color support, an incremental garbage collector, and an experimental just-in-time compiler, and an experimental free-threaded build mode, which disables the global interpreter lock, allowing threads to run more concurrently, that latter feature enabled with Python 3.13t or Python 3.13t.x. Python 3.13 introduces some change in behavior, i.e. new, well-defined semantics, fixing bugs. The old implementation of locals and frame f_locals is slow, inconsistent and buggy, and it has many corner cases and oddities. Code that works around those may need to be changed. Code that uses locals for simple templating or print debugging will continue to work correctly. Some standard library modules and many deprecated classes, functions and methods will be removed in Python 3.15 or 3.16. Python 3.11 adds successor digital verification signatures for all CPython artifacts. Since use of PGP has been criticized by security practitioners, Python is moving to successor exclusively and dropping PGP from 3.14. Python 3.14 is now in Alpha 3. Regarding possible change to annotations. In Python 3.14, from _future___ import annotations will continue to work as it did before, converting annotations into strings. PEP 711 proposes PYBI, a standard format for distributing Python binaries. Python 3.15 will make UTF-8 mode default. The mode exists in all current Python versions, but currently needs to be opted into. UTF-8 is already used, by default, on Windows, for most things, but e.g. to open files it's not, and enabling also makes code fully cross-platform, i.e. use UTF-8 for everything on all platforms. Design philosophy and features. Python is a multi-paradigm programming language. Object-oriented programming and structured programming are fully supported, and many of their features support functional programming and aspect-oriented programming. Many other paradigms are supported via extensions, including design by contract and logic programming. Python is known as a glue language, able to work very well with many other languages with ease of access. Python uses dynamic typing and a combination of reference counting and a cycle detecting garbage collector for memory management. It uses dynamic name resolution, which binds method and variable names during program execution. Its design offers some support for functional programming in the Lisp tradition. It has filter, mapond reduce functions, list comprehensions, dictionaries, sets, and generator expressions. The standard library has two modules that implement functional tools borrowed from Haskell and standard ML. Its core philosophy is summarized in the Zen of Python, which includes aphorisms such as beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. Complex is better than complicated. Readability counts. However, Python features regularly violate these principles and have received criticism for adding unnecessary language bloat. Responses to these criticisms are that the Zen of Python is a guideline rather than a